All right, Unit 4, Lesson 1. What's weird about Unit 3 and Unit 4 is that it might seem like they could all be one chapter, and they really could. Chapter 3 and Chapter 4 really do run together. So if Chapter 3, if the ideas in Chapter 3 were going well for you, you'll find many of these lessons pretty straightforward. So, solving polynomial equations. By now, you should be factoring Jedi. You should have done enough factoring practice that the process is pretty complete. If it's not, here comes more of it. You've got to get this process down. So let's review it. To factor a polynomial, p at x, first we find a k value such that p at k equals 0. Finding that k value sort of seems like trial and error, but there is a systematic approach to finding it. Try 1, then -1, try 2, then -2, and you'll find one fairly quickly most times. Now that you know that x minus k is a factor, divide it out. So divide p at x by that x minus k to find the other factor. And this remainder must work out to 0. That's what that assignment was all about. Repeat the process until you get all the factors down to degree 2. And then any degree 2 factors, you can factor those using methods you already know. Easy? Well, not easy, but with practice it's not too bad because it's very repetitive. So now our motivation at that time was to be able to find zeros of any polynomial so that we could graph them. However, our new skill at factoring allows us to deal with another type of problem that's very, very similar. So here's the example we can do here, and I've written this one completely out for you so that you don't have to do any writing here, because especially if you know how to factor, you'll find this example pretty straightforward. The example says solve for positive x values that make p at x equal to 10 in this polynomial. Oops, there it goes. Back to here. So we want to know not when is this polynomial equal to 0, we want to know when is it equal to 10. So to find out when it's equal to 10, we actually just set p at x equal to 10 right there. So the 10 goes right in here for p at x. I've replaced the p at x for 10. Now, how could this come up in the real world? Well, this equation could be an equation for anything. But for example's sake, think about maybe it's a profit equation, and we want to know when our profit is 10 million. Or maybe we want to know when a population is equal to 10,000 bacteria, or whatever you're talking about. So you want to put a 10 in there. And our first move, and we're going to talk about a lot why this is the first move, is to move that 10 over. That 10 immediately comes over to here because we really want, I'm going to use a red highlighter here, we really want a 0 over here. And I'm going to talk in a minute why it's so important to have a 0 over here. That's our method for solving these equations, is to get 0 on one side. So I collected -2 minus 10 equals -12. And then from there, it's just the factoring procedure from last chapter. So I'm going to walk through it, but fairly quickly here. Factor this thing. So I tried p at 1, and look at p at 1 worked right off the hop there. Didn't take me long to find one that had a 0 there. P at 1 equals 0, and that means x minus 1 is a factor. If x minus 1 is a factor, I got to use a k value of 1, and I do my synthetic division here. Here's the coefficients, 1, 1, -16, 26, and -12. I bring down that first coefficient, and then I'm multiplying by 1 each time I come up and adding. If you don't have that down pat, folks, wow, that's a whole chapter went by that you should have been able to practice that and know how to do it. You've got to get that down. You've got to go back and do some synthetic division, to do some of the factoring homework, enough that you are confident to do one of these. The end result is my original polynomial, x to the power 4 minus, I'm going to switch to really thin underlining here, x to the power 4 plus x cubed minus 16x squared plus 26x minus 2. I found two factors. I found x minus 1, and then through synthetic division, I found these other coefficients, x cubed plus 2x squared minus 14x plus 12. So the procedure is pull off one of the degrees. So what was a degree 4 function is now a degree 3 function. And then I go after that. I let p at x equal x cubed plus 2x squared minus 14x plus 12, the other part of this thing, and I sub in other numbers. So I tried -1, I got 27. I tried 2, and I got 0 there. So I knew x minus 2 was a factor. And I go through the procedure again with my k value of 2, write out the coefficients, and do that synthetic division. Now look what happens here. My original polynomial, x to the power 4, was degree 4. First, I found x minus 1 as a factor. Then I found x minus 2 as a factor. And then here was the remaining factor, x squared plus 4x minus 6, which doesn't factor. There's no two easy numbers that multiply to -6 and add to 4, so you're stuck with the end result of this factoring looks right here. I've got 0 equals. That's how it was different than last chapter, is we're solving an equation this time, and so it's 0 equals x minus 1 times x minus 2 times x squared plus 4x minus 6. So now, this is where it's different than last chapter. Last chapter, we just factored that, and then we were done. Here, we're actually going to solve it because it was an equation we were solving. Look back here. We were solving this equation, not just factoring it. Okay, so when I go back to look at this, there was two factors, and I can pick off two of the zeros right away. If x minus 1 equals 0, x equals 1. If x minus 2 equals 0, x equals 2. But because this last part doesn't factor, this part here did not factor, I'm stuck with the quadratic formula. I sometimes in class call it the she wouldn't factor formula. When it does not factor, the quadratic formula is what you use to solve for the x values. And if your quadratic formula skills are rusty, boy, you're going to need them. They do come up in this chapter and in later chapters. The quadratic formula is not going to disappear. So let me just walk through that fairly quickly. There's the quadratic formula, negative b plus or minus the square root of b squared minus 4ac. We must memorize this. If you're leaning on your calculator, because you've got a fancy calculator that has this built into it, yes, you can use it on the test, but you need to show this step here. The subbing in step, the simplifying step, and the answer. And I'm telling you, you're going to be sorry if you just plug these in and just get the answers. Because at some point, we're going to have to deal with these radicals. Back in grade 11, you dealt with these radicals, and some along the way, we're going to have to deal with those radicals. This question, we don't have to, but we're going to have to deal with it, and so you've got to be able to use the quadratic formula to do those things. End result, type these in, each of these steps, to make sure you know how to use the quadratic formula. I get two other answers, 1.15 and negative 5.15. And why isn't negative 5.15 in the list here? Well, back here in the original question, it says solve for positive x values. So lots of questions will be like this, where they indicate which kind of x values they're looking for. And in a real world situation, there will be these domain issues, these x values that we are looking for in a certain area. Maybe we only want to know for positive time. You saw that with height questions, with the quadratics and so on, where you only wanted positive times and so on. So you got to watch out for that. And so when I found this negative 5.15, I didn't use it because they only wanted positive solutions there. Okay, so what's different about this lesson than last chapter? Only the solve part. Only once we got to here. Everything that came after that, but it should be fairly familiar because it's not that much different than solving a quadratics. The only difference is you get more answers, that's all. So here's the recipe for solving polynomial functions. Substitute in the value required for the function. In the last question, I had to substitute in a 10. Sometimes it'll be 0 you sub in, but you got to substitute in whatever value they're looking for. Move all the terms to one side so that one side equals 0, and that's going to get my fancy red highlighter. One side has to equal 0. It's the only way factoring will work, is if this one side equals to 0. Because if we know that the left side is equal to 0, then we know each of these factors has to be equal to 0. So the factoring method works because we've got 0 on one side. That's the whole reason we do the factoring, is because it tells us that each factor then must be a 0. Only works for the number 0. And then factor and solve for the values in the requested domain. For the example above, the question only wanted positive values. So all that's left here in this lesson is two more examples of that. So if you've done all your factoring homework and you're really good at factoring, you can probably fast forward through a lot of this. And I want to walk through it two more times just to make sure you've got it down pat.
Is there something else?
Okay, so this one. Solve each of the following. 4x cubed minus 12x squared minus x equals negative 3. So what I've got here is someone already subbed in the negative 3. So I know in the question before we had to sub in 10. This one, that's already done for us. So all we've got to do is get 0 on one side. So 4x cubed minus 12x squared minus x plus 3 equals 0. And once I've got 0 on one side, then factoring will work. The only way factoring is going to work is if I've got a 0 on the one side. So, and then I go let p at x equal 4x cubed minus 12x squared minus x plus 3. And then I start this process, this systematic process of trying to find factors. So I go p at 1, and I sub in 1 into this mess. 4 times 1 cubed minus 12 times 1 squared minus 1 plus 3. And I punch that all into my calculator and see what I get there. 4 times 1 cubed minus 12 times 1 squared minus 3 plus 3, I get negative 8. So then I'm going to try negative 1. I'm not going to show all the subbing in there, nor do you need to show the subbing in there. Put a negative 1 in wherever I see 1 there. And I get a negative 12. I'm going to try p at 2. I have 4 times 2 cubed minus 12 times 2 squared minus 2 plus 3 and something went wrong with my calculator there. I just got to do a little repair job on there. I get negative 15. P at negative 2. Negative 75. P at 3. Zero. Finally, I found p at 3 equals 0. So therefore, x minus 3 is a factor. So I can divide that off with my k value equal to 3. Here are my coefficients, 4, negative 12, negative 1, and 3. Bring down the first one, multiply by 3. It gets 0 there. Isn't that weird? 3 times 0 is 0. Add them together, I get negative 1, negative 3, and 0. So what I have is x minus 3 times 4x squared minus 1 equals 0. There was no x term in the middle there. And that's why I had so much trouble finding a 0 there, is because there was very few pieces there. Now, look at this mess here. This part I can do, this x minus 3, this first part here, that's no problem. But the second part is 4x squared minus 1. Not obvious what has to happen there. And there's lots of ways to handle this. You could isolate. You could do this. You can go x minus 3 equals 0, or 4x squared minus 1 equals 0. You can actually just solve for x here by isolating x there. That would work, no problem. You could do the quadratic formula. That would work. But this actually does factor. It's a difference of squares. So I get 2x plus 1 equals 0, or 2x minus 1 equals 0. So I get x equals negative 1/2, or x equals 1/2. I got two awesome choices there. Okay. So what I'm going to do is I'm going to break that video into 2 pieces. So that's one more example. And then the second video, what you're going to see is that last long example there. So it'll be 2 videos. So tune in for the second video because this one has a situation to deal with. So even if you really know what's going on, watch at least for the first few minutes that